All right, we're going to continue the optical isomers, and we are going to draw the optical isomers today and see what is the difference, right? So any organic compound, so just quick review of what we did in the last class. We did optical isomerism. When an organic compound is not symmetrical or asymmetrical, they have the phenomena of optical isomerism, right? There are two types of the basic thing that is required to be to represent the phenomena of optical isomerism is the chiral carbon, right? A carbon which is attached with four different atoms or groups is known as chiral carbon. Okay, when it is attached with four different atoms or groups, it is known as chiral carbon. Okay, so we learned how to identify the chiral carbon. Today we are going to draw how to draw the optical isomers. For example, there is a compound. Please look at this: CH3CH. OH, CH2, and then CH3. Can you please look at this? Is there any chiral carbon in this compound? Yes. Which carbon? This one. So when you are about to draw the optical isomers, now listen to me carefully. Okay? When they ask you, okay, now you got this compound contain a chiral carbon, so it's going to show the phenomena of optical isomerism. So when it shows the phenomena of optical isomerism, then you have to draw the optical isomers. In order to draw the optical isomers, you have to write that carbon, which is a chiral carbon. Idhar dekho bachcho, ye wo chiral carbon hai. Then when it has four different groups, so iski geometry hogi tetrahedral. So you have to show it in three-dimensional. Tetrahedral mein, when you show it in three dimensions, two are along the plane. One is the triangle coming out of the plane. Yes, and there is a dashed or wedged line that is going behind the plane. So now four atoms or groups that are attached, you just put them in the order, any order you want. But I usually do, or I must do, कि हाइड्रोजन को मैं इस पे लगाता हूँ, ये जो wedged line है, ये dashed line, इसका मतलब है going back of the plane. और ये जो triangle होता है, इसका मतलब होता है coming out of the plane, right? Rest I can put anything. Let's say OH is here. Let's say CH3 is here. And right, CH2 and CH3 is here. This is the one of the optical isomers. Ye ek hai. And then you put a mirror. You just think that there is a mirror here. Okay. So when I put this mirror in front of this, तो इसकी एक image बनेगी. And we all know कि mirror में जो image बनती है वो हमेशा क्या होती है? It is always inverted image. As we stand in front of mirror, we can see the image, our form, वो inverted होती है. We are facing the image and image facing us. So the inverted image you have to draw here. This is inverted image. Here. And then this one here. Now you have to invert. You see the dashed line that was on this side, it is gone to the other side now. Okay, so the hydrogen here, OH को मैं HO लिख देता हूँ, CH3 को H3C लिख देता हूँ. Even if you don't invert these things, that won't make difference, but you should. ये CH3 CH2 बन गया. Here it is. So these two are actually the optical isomers or enantiomers. Why they are optical isomers or enantiomers? Why are the optical isomers and enantiomers? Because they are non-superimposable mirror images, right? You see, non-superimposable का मतलब है कि if I take this image and put it on the top of this, carbon के ऊपर carbon होगा, CH3 and OH, they will be on top, but this CH3, CH2 would be on top of what? Hydrogen. So impose नहीं हो रहा ना, impose का मतलब है all the groups fit in. Okay, so they are non-superimposable mirror images. That's why they are known as optical isomers or enantiomers, as they are non-superimposable mirror images. So now you understand why it needs four different groups, because if there is only one of them common comes in, so they can't be a non-superimposable mirror images. But keep in mind, you have to invert the image. You see the dashed line should go on the other side to make optical isomer or enantiomer, right? And one thing more which you need to understand. Now, if you look at these two optical isomers, you must be thinking their molecular formula is same. Their molecular formula is same. Their structures are same. ऐसे ही their functional groups are same. Everything is same except the orientation. So therefore, even unlike cis trans isomers, these two have even molecular formula and even the melting and boiling points same. The only one difference between these two isomers is, you know what is that? They just rotate the light. For example, if this cup containing one of the optical isomers and I switch on the light and throw away it, it's going to turn to this side, the right hand. And if I switch on the light, the other isomer is going to turn to this side. So they only rotate the plane of polarized light. That's why they are called optical isomers, right? Nothing else is different. So keep in mind the optical isomers, molecular formula same, structural formula same, chemical properties same, physical properties, everything except one property. Light. Yes. So when the light strikes the plane polarized light, one of them rotates to one side and the other one rotates to the other side. So please write down optical isomers are enantiomers. Each isomer rotate the plane of polarized light in opposite direction. Okay. Otherwise, the other two, every other property is the same. Okay. So this is how you look at the and even if they are present in equal amount, they, for example, both of them, if they are present in 50-50 in a mixture, that mixture is known as racemic mixture, and that actually would not affect the light rotation, right? So racemic mixture usko kehte hain when they have equal amount, the both isomers in one mixture, and then they have no even effect on the light even, right? So they can't even rotate the plane of polarized light, right? So just write down racemic mixture. हमारे सिलेबस में तो नहीं आता, बट जस्ट एक एडिशनल बता रहा हूँ. Racemic mixture contains 50% of each isomer, or equimolar mixture no optical activity. Okay. Okay, that's all about these optical isomers and how you draw them, right? So they are non-superimposable mirror images, right? Known as optical isomers or enantiomers. And whenever they ask you to draw, you have to draw like this, as I have, right? So that's all about the optical isomerism. and I think we did few questions from there as well, right? So that's all about the isomerism. So I'm gonna go through some questions right now again, and then we'll move on to the next topic, right? Look at this, for example. We have the test for the isomerism and this on this Friday. Friday को naming and isomerism और structural वगैरह का test होगा. Okay, please, parents. For example, can you look at this? How many geometrical cis-trans isomer are there for a hex 2,4-diene? Please, parents. Hex 2,4-diene. Can you show me the cis-trans isomers? How many? Cis-trans. Okay. So let's see. So CW. Zero. No carbons. Yeah. Cis-trans. Because there are no carbons. Zero. Cis-trans. Which cis-trans means that switching. Yeah. Cis-trans. Yes. There's a double bond for the cis-trans. The basic condition is carbon-carbon double bond. Is there any carbon-carbon double bond? There is a. So. To the power of 8. There is a formula that number of isomers in order to see at cis-trans 2 raised to the power number of double bonds. So 2 raised to power 2 is equal to what? 4. So how many isomers does it have? 4. 4. But unfortunately, in this case, if you look at this, please parents. Please parents. Please parents. If you look at this, here it is. यही है ना? Now, in this case, as the two ends are exactly the same, sorry. If you are using the formula, keep in mind that these two ends are the same. The isomers which we did when we were doing this, you know, one is cis. That is the first isomer. If you switch the position of that thing, so cis, trans, then if you position of this thing, trans, cis, and finally fourth one is what? Trans. But in this particular case, ये जो बीच वाले दो हैं, they'll be one. क्योंकि इनके जो दोनों ends हैं, they are exactly the same. So cis, trans, and trans cis, in this particular case, will be a same isomer. So there'll be one isomer. So hence 1, 2, and these two are the same. So 3 isomers. So whenever there is a double bond, formula यही लगेगा. So my conclusion is the formula remains the same. But you have to look at this clearly. If the two ends are exactly the same groups attached, or they are looking the same, so वो बीच के जो दो isomer होते हैं वो एक ही होगा. So 1 minus कर देना. So 2 raised to power 2 is 4. So subtract 1 to get 3. So अगर 8 होते हैं, फिर minus 1 करते हैं, फिर minus 2 करते हैं. क्योंकि फिर वो लास्ट दो सेम आ जाते हैं ना. Cis trans और trans cis सेम होते हैं. Okay, so exactly what I'm trying to say. Okay, once you draw them as I have drawn them here. So the first isomer is cis-cis. When I'll draw the second trans-cis and cis-trans, they'll be the same isomers. That's why the total number in this case is not 4. It is what? It is 3. Okay, so one thing. And then how many chiral carbons? How many chiral carbons? या जस्ट 1 मिनट यही है क्वेश्चन ही करा रहा हूँ मैं भी इसको एक्सप्लेन करता हूँ कायल कार्बन ढूंढना है और जो पहले कराया वो मैं भी करा देता हूँ Is this carbon chiral? Yes. This one, this one, this one, this one, this one. So I'm not doing any kind of breakage even. जहाँ जहाँ 3 bond निकल रहे हैं मुझे पता है it's a chiral. So I just start marking them. 1, 2, 3, 4, 5, 6, 7. So how many chiral carbon? 7? Yes. Okay. Okay, here is the compound. Which compound exhibits the phenomena of stereoisomerism? Double bond. Stereoisomerism में both आ जाते हैं, cis trans भी और optical भी. Both cis trans and optical. Let's start with A. No, stereoisomerism अभी तो किया है. Cis trans and optical. क्या अच्छा नहीं जो अभी ये वाला नो ऑप्टिकल है Does the A has the phenomena of stereoisomerism? Stereo में both आते हैं ना? हाँ, so optical के लिए क्या देखना है? Chiral? Carbon. और cis trans के लिए क्या देखना है? Okay, the first one. Let's start with the first one. It is CH3. It is CH, Cl, and then CH3. Is there any double bond? No. Is there any chiral carbon? No. No, so there is no phenomena of stereoisomerism. The second one, CH3, C, H, Cl, C, H, H, and then Cl. There is no double bond? No. There is no double bond. Is there any chiral carbon? This one? Is this carbon chiral, bacho? Yes. 1 CH3, 1 H, 1 Cl, and 1 CH2Cl. Yes, it is a chiral carbon. So it will have a phenomenon of optical isomerism. Okay? And stereoisomerism is one of the optical isomerism. The साथ वाला नहीं, because 2 hydrogens हैं उसके ऊपर और नीचे. Okay? The next one, वैसे by the way सबको देख लेते हैं. Next one is CH3. C और 2 क्या है इसके साथ? Cl. So no chiral carbon in this. और last वाला देखें. CH2Cl and then CH2 and then CH2Cl. Is there any chiral carbon? No double bond, no chiral carbon. So hence the only B is the one because of the chiral carbon shows the phenomenon of optical isomerism. ये question आपने गौर से करना है. This is a cash prize. Yes, some vegetable oil contain trans fats that are associated with the undesirable increase in the amount of cholesterol in the blood. In the diagrams below, R1 and R2 are the different hydrocarbon chains. So please point to be noted. Which diagram correctly illustrates the optical active trans fat? Optically active trans fat. ऑप्टिकली एक्टिव क्या मतलब है उसमें ऑप्टिकली एक्टिव अभी मैंने ऊपर बताया ऑप्टिकली एक्टिव का क्या मतलब है लाइट रोटेशन यानी उसमें क्या होना चाहिए और वो किस में होती है जिनमें कौन सा कार्बन होता है यस सो इट शुड हैव अ कायल अब तो मैंने बता दिया कैश इज विथड्रॉन सो कायरल कार्बन होना चाहिए एंड ट्रांस फैट है ये ओके नाउ गिव इट अ शॉट No, I really wanted to. But this time, it's my fault. कि मैंने उसका hint दे दिया. So next question. Yeah, next अगर कोई आया तो. But इसमें मैं was optically active mean you have to look for the chiral carbon. Okay, पहले में तो कोई कायरल कार्बन मुझे नजर नहीं आ रहा, कोई कायरल कार्बन नजर नहीं आ रहा. Then what about this? कोई कायरल कार्बन नहीं नजर आ रहा जी. Let me show you again. Hello. जी, can you please explain?
So I suppose
Look at the chiral carbons. कोई chiral carbon है इसमें? ये ऊपर और नीचे R1 CO2 CH2 और R1 CO2 CH2, they are the same groups. These two groups are the same. What about B?
B is the R1 R2.
What is B? Look at the B.
The B which one I think it's B. So B is the B6.
Need to speak after the class. B, does it have a chiral carbon?
I think so. No, but then it's
Just look at this carbon.
So it's attached to R1 and R2 different chains.
R1 and R2 are the different chains. So it's a chiral. And now look, is it a trans or cis? Yes, so this is optically active trans fat. Okay? No, unfortunately. और ये देखिए, ये भी optically active है. This is the chiral. लेकिन ये कौन सी फैट है? Cis fat है. ये भी cis fat है, लेकिन ये optically active नहीं है. दोनों में क्या है? R1.
Did we? Yeah. I'm like 90% sure we did. Why would I remember it?
Structural isomerism and stereoisomerism, अब देखिए, should be considered when answering this question. How many isomers with the formula C5H10 have the structures that involve pi bond? Right? How many structures that involve pi bond?
What is pi bond? Pi bond numbers. Okay, I mean, I know what pi bond is, like, what does that mean? Cis? I'm pretty, I don't know. Honestly. I feel like we did very similar question to this previous years.
Structural isomers and stereoisomers should be considered when answering this question. Okay, now let me tell you what you have to do. Please pay attention. आपको सारे आइसोमर ड्रॉ करने चाहिए. 1, 2, 3, 4, 5. Pent 1 in. 1, 2, 3, 4, 5. And here is the methyl. And then one more not possible. 1, 2, 3 करेंगे, डबल बॉन्ड लगाएंगे, ये करोगे तो नहीं होगा, क्योंकि वो ब्रांच नहीं लगा सकते ना, 2 ब्रांचेस, बिकॉज कार्बन के 4 बॉन्ड से ज्यादा हो जाते हैं. Now let's change the position of these. ये पेंट क्या हो जाएगा? 1, 2, 3, 4, 5. This is pentene. And then what next? नहीं, इसी की पोजीशन चेंज करते हैं. 1, 2, 3, 4. ये यहीं रहे, ये यहाँ चला गया. फिर एक और भी चेंज कर सकते हैं. 1, 2, 3, 4. ये यहीं रहे, डबल बॉन्ड इधर चला गया. ओके,
So 5 structure. No, 5 structure you can make with the stereoism.
इससे ज्यादा लेकिन नहीं. इससे ज्यादा अगर कहे तो उन्हें कहना, फिर मेरा वो करें.
For that one, maybe we consider the function. No, I think we can do it. नहीं, देखो ये एक चक्कर और एक. No, I don't think there's any stereoism. We can 5 ही है.
No, you have to consider structural and stereo both. Structural तो 1, 2, 3, 4, 5 आ गए हैं. Why don't you consider stereo? Stereo is trans and optical, both. So there's a lot of job to be done. पहले वाला पेंट वन इन में तो सिस ट्रांस नहीं होगा, वन इन कैन नॉट हैव सिस ट्रांस, पेन टू इन कैन, सो इसमें तो सिस ट्रांस नहीं है और ऑप्टिकल भी नहीं है। ये पास रखें अगर उनका दोबारा कॉल आती है।
लेकिन सर उसमें कायरल कार्बन नहीं है,
Sorry,
सर पेंटुइन में कायरल कार्बन,
pentuene can have cis and trans. So actually when I told you the other day when cis trans isomerism होता है तो फिर दो आइसोमर नहीं होते, एक ही होता। I mean, my apologies. फिर pentuene is nothing. Pentuene has always two molecules, cis pentuene and trans. So I'm going to consider them two here. Okay, they're not one isomer. There are two isomers. Now, what about this one? Do they have cis trans? Okay, what about this one? Do they have cis trans?
Max number 6, so it's obviously no.
No?
No, so look, 6 is the max.
And again, this is so again, there's no cis trans because of this. और कोई भी इनमें chiral carbon नहीं है. So when there's no chiral carbon, no optical isomer. So the maximum number has achieved 6. So 1, 2, 3, 4, 5, and 6. 5 and 6 इसलिए कि इसको दो consider किया. Is it clear now? So this is how they ask you. When they ask you to consider all structural and stereo, structural and otherwise. So you have to consider all the isomers, structural as well as cis and trans. Okay? बट एक अगर वो ये वाली शिक ना लगाता ना, इन्वॉल्व पाई बॉन्ड, तो फिर नंबर और भी बढ़ सकता था। अगर वो पाई बॉन्ड वाली शिक ना लगाता तो यू नो के एल्कीन्स का साइक्लो एल्केन के साथ भी एक फंक्शनल ग्रुप आइसोमर बनता है, सो 7 हो जाते, बिकॉज इन सब का एक और आइसोमर होता और वो क्या होता, दैट शुड बी लाइक दिस, साइक्लोपेंटेन, cyclopentane hota. Okay, next. Okay, in these type of questions they ask you empirical formula. Okay, मैं एक करवा देता हूँ। इसका तरीका ये होता है कि you have to count the total number of carbon and hydrogen. For example, this one is 6 and this one is 6. So C12 and hydrogen is 1, 2, 3, 4, 1, 2, 3, 4. Okay, so C12, H4 and then N2. This is the molecular formula. I just yes, divide by 2 to get the simplest ratio. So this is C6, H2, N. So this is the empirical formula. So ये बार-बार आएगा. They'll ask you to calculate the empirical formula. So you have to calculate the molecular formula and then divide it by 2 to get to the empirical formula. Right? Compound X does not show cis trans isomerism. Please mind this, does not show cis trans isomerism. Okay? So what could be the identity of compound X? What could be the identity of compound X?
This is not just made double bond now. So double bond now. So
does not show 1,1,2 trichloropropene double bond तो इन सब में है. Then does not show 1, 2, 3 propene है ये double bond और 1, 1 यानी 1 पे और अब तो नहीं हो सकता 1, 1, 1, 1 अगर आ गया है तो it means two similar atoms आ गए ना डबल बॉन्ड वाले कार्बन के साथ, so cis trans नहीं होगा. Okay, 1, 2, 3. So 1, 2, 3 is like this. This is 1, this is 2, this is 3. Okay, so क्यों नहीं हो सकता? Yes. अब देखिए इन दोनों कार्बन जिन पे डबल बॉन्ड है 1, 2, 3 ट्राइक्लोरोप्रोपीन में हो सकता है ना. These two are the different atoms. These two are the different. तो होगा ना इसमें, it would have a cis trans isomerism. Okay, 1 chlorobutadiene. Okay, does not show the cis trans isomerism. Does not. तो does not का तो आंसर आ गया. We just trying to find out. तो 1 chlorobutadiene में होगा या नहीं होगा? 1, 2, 3, 4 ये 1 chlorobutadiene. What do you think? होएगा because two different है. So इसमें भी होगा. See, आंसर हमें मिल गया है. Does not उसने कहा था तो does not तो वही है ना. Okay, 1 chlorobutadiene.
वो भी दिखाएगा।
ब्यूटेन में तो वैसे ही होता है, आपको पता है, वन इन में नहीं होता बिकॉज हाइड्रोजन आ जाते हैं, बट इसमें क्यों आ गया? बिकॉज ऑफ क्लोरीन. Which compound have the optical isomers? Out of these three, which compound has optical isomers? Mean it has to contain what? Chiral carbon. So which compound has chiral carbon? ये तीन chiral है. What about this? Chiral, chiral, chiral. Okay. What about this? No chiral. Okay.
How can they first transmit together because they have only two different groups?
This one.
Yes.
This is one. This is two.
There's only two groups. For current, there are three groups.
Four.
Four, so there is only two groups.
With you're talking about number one.
Yeah.
Number one में ऊपर इस कार्बन में CHO है, नीचे इधर OH है, दो हो गए, इधर H है, तीन हो गए, और ये सारा हो गया, तो चार हो गए ना. ओके राइट. और इसमें तो वैसे ही हमने कहा है कि ये कायरल हैं, तीन कायरल हैं. ओके इसमें कोई कायरल नहीं है, तो नो ऑप्टिकल आइसोमेरिज्म बिकॉज ऑफ द डबल बॉन्ड्स. X has a molecular formula C5H12O, probably an alcohol. The CnH2n plus 2O. Okay, kind of surely. X has a branched carbon skeleton and secondary alcohol. Now surely, functional group. So it's a branched and it's a secondary alcohol. How many structures isomer fit this description of X? What I told you, just start doing the work, draw all of them, और फिर जो आपकी इस डिस्क्रिप्शन में फिट होंगे वो आप बता दीजिएगा. फॉर एग्जाम्पल C5 के हमने बनाए हुए हैं 1 2 3 4 5 विद OH. एक ये हो गया, ये तो हमें चाहिए नहीं ना, बट हम क्योंकि वो जो रट्टा है उसको फॉलो कर रहे हैं. 1 2 3 4 OH with 1 here, ये भी हमें नहीं चाहिए. फिर आ जाएगा 1 2 3 with OH, ये भी नहीं चाहिए. ओके बट अब इनके आगे पोजीशन आइसोमर्स 1 2 3 4 OH, ये भी हमें नहीं चाहिए क्योंकि उसने कहा ब्रांच होना चाहिए. सेकेंडरी तो है लेकिन ब्रांच नहीं. ओके फिर इसमें एक और आगे ले जाता हूं 1 2 3 4 5 OH, ये भी नहीं चाहिए क्योंकि सेकेंडरी तो है लेकिन ब्रांच नहीं है. ये हमें चाहिए होगा. यस इसमें वो कहता है अगर आप इसमें आगे ले जाते हैं 1 2 3 4, इस कार्बन को अगर मैं इधर लगाऊं तो वो तो टर्शरी बन जाएगा ना, वो भी हमें नहीं चाहिए. हाँ अगर मैं एक और आगे ले जाता हूं 1 2 3 4 और ये OH, ये चाहिए बिकॉज दिस इज द ब्रांच्ड एंड सेकेंडरी एज वेल. फिर आगे ले जाऊंगा तो प्राइमरी बन जाएगा, उसमें आप पोजीशन मूव नहीं कर सकते. सो आंसर इज 1.
जो लास्ट में आपने बनाया तो उसकी कार्बन की बॉन्डिंग लेफ्ट से होगी या राइट से होगी?
कौन सा वाला? 1 जिसमें OH नजदीक है. OH कहां से नजदीक है? OH जहां से नजदीक होगा, OH is on the left side ना, तो बस उधर से होगा. So that only fits our description. Which pair of alcohols are the isomers of each other? Butane 1-ol and 2,2-dimethyl propane 1-ol. Butane 1-ol मतलब 4 carbon and so C4H10O है, and 2,2-dimethyl propane 1-ol. No, because 2,2-dimethyl propane 1-ol mean 3 carbon and 5 carbon, so they can't be the isomers. Then butane 2-ol and 2-methyl propane 2-ol.
Yes.
That could be, but let's draw it. So butane 2-ol 1 2 3 4 is this, and then what about 2-methyl propane 2-ol? 2-methyl propane 2-ol. Okay, so this is 2-methyl This is propentuol. Okay?
So it is.
It is? Because in dono ka molecular formula is C4, H10O. Structure is different. When the molecular formula is the same and structure different, they are known as structural isomers. So, बच्चों, you have to follow in the MCQs के आंसर तो लिखे होते हैं, but there is a thought process which I'm trying to make you learn. कि जब क्वेश्चन देखते हैं तो क्या thought process होता है आपका, right? So that is I'm just trying to explain. Okay, what about the compound shows? I think we did in the last class.
ये क्या था सर?
Which compound shows geometric or cis trans isomerism? इनमें से कौन से कंपाउंड है जो cis trans isomerism शो करते हैं? First one, carbon carbon double bond है, एक CH3 है, एक H है, there is CH3, there is C2H5. Does it show?
Yes, sir.
Yes. क्योंकि double bond भी है and all that stuff. Why not? डबल बॉन्ड है, इसमें H है, इसमें CH3 है, इसमें H है, इसमें CH2, CH2, CH3 है. Why not?
It does.
It does. Because double bond is there, two different atoms with each carbon are there. Sorry?
3
Double bond H और ये क्या है? C2H5 H C2H5. Okay? Next. How many sigma bonds present in this molecule? Sigma bond single bond को कहते हैं. So you just have to count the number of carbon bonds. जैसे ये CH2 है, तो ये देखें. ये. What about this or the other one? So this one I'm telling you, CH2 mean two. ये पहला bond sigma होता है ना. So this is 1 sigma, 2 sigma, और इन दो में से एक sigma है. 3. Then next 4 है, तो एक क्या हो गया? Sigma. फिर आगे C H H, फिर ये 5, फिर ये 6, फिर आगे क्या है? C double bond O, फिर ये क्या है?
7.
So did we count with 8?
Yes, 7 and then 8. तो दो है ना, दो में से पहला काउंट होता है सिग्मा, दूसरा नहीं काउंट होता. फिर अबाउट ये सिग्मा हो गया 9, फिर O, फिर ये सिग्मा हो गया 10, फिर ये दो सिग्मा हो गए 11, 12, फिर ये आगे एक सिग्मा हो गया 13, 14, फिर आगे दो है तो देयर इज 1 सिग्मा 15, फिर ये आगे 16 नहीं, मेरा ख्याल है कोई मिस कर गया. हम शुड या
This left side traveling is K. Fourth of it.
fourth and yeah, this is the one which is missing. Here it is the one that is mixed, so 18 is the number. No, अभी बाद में कराते. So इधर देखिए, चले मैं इसको थोड़ा चेंज कर देता हूँ. आपको सिर्फ इसमें बताने हैं कायरल कार्बन कितने हैं. वैसे क्वेश्चन ओरिजिनली कुछ और है. So how many chiral carbons in this? How many chiral carbons?
One guess what?
I think too early, too much oversimplifying. ये कार्बन है, तो तुक्के तो ना मारो ना. और कहाँ है? ये दोनों CH3s हैं, ये भी CH3 है और ये भी CH3. ये दो CH3s अटैच है ना इसके साथ. ये इसके साथ दो CH3s अटैच है. इसके ऊपर वाला डबल बॉन्ड है. ये डबल बॉन्ड है. कौन सा? वो डबल बॉन्ड है. ये वाला डबल बॉन्ड है. ये भी डबल बॉन्ड है. There is only one. क्वेश्चन एक्चुअली ये था कि जब आप इसकी कंपाउंड की करते हैं ना हाइड्रोजनेशन, क्या करते हैं? हाइड्रोजनेशन करते हैं तो ये डबल बॉन्ड भी खत्म हो जाएगा, ये भी खत्म हो जाएगा, यानी सिंगल हो जाएंगे, और ये भी सिंगल हो जाएंगे. फिर कितने हैं? If they are all single bonds, then what? फिर ये भी है, ये भी है, फिर ये तो है ही है, फिर ये भी है, और फिर ये भी है. So then how many? 5. Okay. How many chiral centers present in the molecule of G? Is this? So कितने हो गए? उनके साथ दो CH3s. This one has two CH3s. Okay, which compound does not exhibit cis trans? Does not. Sorry, my apologies. Okay, stereoisomerism may cis trans and optical.
So whichever one doesn't have
Cis trans.
It's not.
Okay, cis trans and optical G. A में होगा. A does contain chiral carbon G. तो does not हमने ढूंढना है does not वाला. तो A में optical होगा because it contains a chiral. What about B?
Does not contain a chiral.
CH3 CH फिर आगे क्या है? डबल बॉन्ड होगा जी, जो उसने शो नहीं किया, ट्रिक किया है हमें. सो इसमें सिस ट्रांस हो जाएगा. ओके, वो उसने शो नहीं किया ना. ओके, व्हाट अबाउट दिस? नो, CH2Cl और फिर CH2 और फिर आगे Cl2. ये Cl और ये H. इसमें भी नहीं है. इसमें उसने डबल बॉन्ड नहीं शो किया हुआ ना. D में डबल बॉन्ड है, H और Cl. तो यही हो गया C. ओके, राइट. विल कंटिन्यू दिस जी. नेक्स्ट हम कल एल्केन्स शुरू करेंगे. थैंक यू.